This prototype integrates embroidered wearable antennas. Conformal designs ensure lightweight physiological sensing. Systems is 5G ready and fully connected.
And today I am here to present my seminar on wearable antenna. So, as we know, what is antenna? But before starting to my topic, I would like to share a small story from history. Like in 1940s, 50s, or 60s, the war changed the total electronics engineering and further technologies. Like USSR used radar, satellite communication, wireless communication for war. And we realized that electronics or engineering played a huge role in warfare. And for the future will be totally 99% depend on technology. So I introduced my antenna, wearable antenna, and their application, future, and further future scope and applications in military uniform. So as we know, why do we need wearable antenna? Wearable antenna is just like conventional antenna, but we require flexibility, lightweight, compact handles, movement reliable. Because if we use wearable antenna in your clothing, our movement will break the antenna. So we require such material so that they can be flexible and unbreakable during unresilient movements. And it should be low profile, like its dimensions should be minimum. So I shared you story that how wearable antenna is evolved. In 1990s, we used body-worn communication for the textile antenna, smart wearable antenna, intelligent wearable antenna. Now the 2025, 26, 27, further till 2050, the 6G connected clothing will be introduced. According to my research, it will be used in military communication. Okay. Why and what wearable antenna do and how it can be constructed? A wearable antenna is designed to operate on a human body, near to human body, inside clothing or wearable equipment. Like we can use it on helmet, shirt, shoes, necklace, watches, etc. Basic structure, we have three layers. First, radiating element, flexible substrate and ground plane. Radiating element, it must be like conductor, copper, aluminium, graphene, graphite, anything else. But it should be flexible. And further, we use flexible substrate also because we require flexibility during our resilient movement because it should be bendable and ground plane. How does the wearable antenna work? It is a 5-step process like a simple conventional antenna works. First, a time-varying current is used to propagate the signal through antenna. The antenna break the signal into environment or shared into free space, and then the signal is received by further receiving antenna. Types of wearable antenna: textile antenna, micro strip patch antenna, flexible antenna, embroidered antenna, helmet integrated antenna, and wrist-worn antenna. So let's move further. Material used in wearable antenna. Like I shared you a story, the army using antenna that are made for rigid electronics. Like we are using microstrip patch antenna, which is used in our mobile phone, which is MIMO antenna, multi-input, multi-output antenna. So, but it is rigid. If we move, if we try to apply force, it will be bent. So we require a flexible material like conductive fabric. What is conductive fabric? Like copper, small copper minimum thin wires are used to made a thin sheets of flexible material, graphene based material. Now in 2024 or 25, the graphene based antenna is introduced by US Army Research Laboratory. They are using this antenna in army equipment. How antenna is integrated into clothing? There are some ways, but these are four compact and easily equipped ways. First, embroidery. The antenna is directly stitched to the uniform. I will be share you a video in next printing. We can use a conductive way, and the antenna can be printed on T-shirt and anything else. Weaving, as we know, our sweater is weaved, so like that the conductive are used for this weaving. Flexible patch and integration will we use printing, weaving, or embroidery, but we have a minimum fundamental wire of copper, aluminium, gold, or anything else. So we can use a patch. Patch something like a planar box. Wireless body area network. What is wireless body area network? It is nothing but a network which is totally near the human body. But we have a wearable antenna on a clothing. It requires several changes in to adapt with human body, because human body have water tissues which absorb electromagnetic wave. Like some electromagnetic energy may be absorbed. So if energy is absorbed, the signal integrity, signal strength, and signal power will be decreased, and communication range also decrease, and our communication will be affected. So we use some safety measures like specific absorption rate. For human body, it is desirable like 1.4, 1. Like in India, it is 1.6 watt per kg. And ACR is how much a body can absorb electromagnetic wave. Major challenges in wearable antenna. Despite we have flexible fabrics, but they are not sufficient to make a proper, fully communicated wearable antenna for uniform of army. So we are using hidden trial method, using different materials, using different technologies. Like we are using metamaterials. Metamaterials are those substances which are just like normal materials, but they are manipulated. Their atoms and molecules are manipulated according to smart military uniform. My vision is to make a smart military uniform for Indian Army. So this is a major fundamental for uniform is wearable antenna, because if we know in an army, a group of 5 army personnel, they use several communication systems separately. It has major weight. They carry guns, food, etc. They don't have any other carrier. So they use some feasible thing that they can carry anything anywhere. How a connected soldier system works? Like a wearable antenna works on 5G, Wi-Fi, Bluetooth, or 6G, or upcoming generation. So we can use in helmet, uniform, tactical vest, body sensor, command network. So this is image showing that wireless antenna is stitched on his shoulder. Recent advances in wireless wearable antenna, smart textile antenna. The antenna is directly fabricated into cloth. Stretchable antenna, like we know about the rubber. It is stretchable, so we can use mixture of rubber and copper, so we can make a stretchable antenna. Graphene based antenna is similar, like we can use graphite and conductive materials with graphite. Energy harvesting, as we know, the size of antenna of microwave, 5G, Wi-Fi, they are very compact and very low dimension. So they require very low power, low energy consumption. So we can use solar power, body heat, and movement of a soldier. So we can use this energy to convert into electrical energy. And AI, now we use CST, HFSS, etc. for antenna design. So I have introduced that AI assisted design. We can train a model using Python libraries. So we can design a specific targeted antenna for 5G. We require a specific dimension to make the antenna. Multi-antenna system. It is nothing but it is simply an antenna array fabricated on a single uniform. Like we use 5G antenna, 5G antenna attached on a single patch. So it is like multi-antenna system. Which countries are working on in this technology? Like, as we know, America is way ahead from other countries, America and China. So America is working on defense wearables, and wearable antenna is a major part of it. And other countries are also doing, but India is in backward position. Global investment and market ecosystem. Till 2005, the global investment is $92.9 billion. It means it is a huge market for startup doing in defense electronics. Like we are using wearable antennas, smartwatches, health